Hello everybody, welcome to the trigonometric equations video. Please take notes in your note packet and remember that you can pause, fast forward, or rewind at any time. For this video you will need your unit circle. Remember that the cosine of theta is the x value of the corresponding point and the sine of theta is the y value of the corresponding point. And also take out a unit circle with your tangent values on it. Part 1. Basic trig equations. Solve for x where 0 is less than or equal to x and x is less than 2 pi. Our basic strategy is to isolate the trig function and then find the appropriate angles using our unit circle. For number 1, we have 2 sine of x equals 1. First, divide both sides by 2. The 2's cancel. We have sine of x equals 1/2. So now we have to find all the angles where the sine value is 1/2, and our angles have to be between 0 and 2 pi, including the 0 but not including the 2 pi. So take out your unit circle. The angles where the sine value is 1/2 are pi over 6 and 5 pi over 6. If you look closely, you'll see for those angles the sine value is 1/2. So our solution is x equals pi over 6 and x equals 5 pi over 6. Note that any angle coterminal to these solutions are also solutions. Therefore, we say the general solution is x equals pi over 6 plus 2 pi n, or x equals 5 pi over 6 plus 2 pi n. The directions are just asking for these two solutions. Number 2, cosine of x equals negative cosine of x minus root 2. First, isolate the trig function. Do that by adding cosine of x to both sides. You'll get 2 cosine of x equals negative root 2. Now divide both sides by 2. The trig function is isolated. We have cosine of x equals negative root 2 over 2. So we want to find all the angles between 0 and 2 pi where the cosine value is negative root 2 over 2. Ding 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 ding! Unit circle, here it comes. Okay, let's see. When x is 3 pi over 4, the cosine value is negative root 2 over 2. And when x is 5 pi over 4, the cosine value is negative root 2 over 2. So we found the two angles. X equals 3 pi over 4, x equals 5 pi over 4. Number 3, 5 times secant of x minus 4/5 equals 3 secant of x. We have to distribute the trig function, so first distribute the 5 to both terms. We get 5 secant of x minus 4 equals 3 secant of x. Next, subtract 3 secant of x from both sides. We get 2 secant of x minus 4 equals 0. Now, we're going to add 4 to both sides and divide by 2. We'll end up getting secant of x equals 2. So now, our trig function is isolated. Since the secant value is 2, that means our cosine value has to be 1/2, because secant values and cosine values are reciprocals of each other. Now we can use our unit circle to our advantage. We need to find the angles where the cosine value is 1/2. Okay, so take a couple seconds and look for those angles. The angles are pi over 3 and 5 pi over 3, because for those angles the cosine value is 1/2. So our solution is x equals pi over 3 or x equals 5 pi over 3. Part 2, square root method. The directions remain the same. Solve for x where x is between 0 and 2 pi. 0 is included, 2 pi is not. Our strategy is the same. We need to isolate our trig function. Number 4, 3 times tangent squared of x minus 1 equals 0. To isolate the trig function, add 1 to both sides. We get 3 tangent squared of x is equal to 1. Now divide both sides by 3. Tangent squared of x is equal to 1/3. To isolate the trig function, we're going to take the square root of both sides. If we take the square root of both sides, we get tangent of x equals plus or minus, and you can rip radicals apart like this. Tangent of x is equal to plus or minus 1 over root 3, which rationalizes to plus or minus root 3 over 3. Okay, so let's summarize. We're trying to find the angles where the tangent value is plus or minus root 3 over 3. Let's take out our unit circle and find those angles. The tangent of pi over 6 is root 3 over 3. Tangent of 7 pi over 6 is root 3 over 3. Tangent of 5 pi over 6 is negative root 3 over 3. Tangent of 11 pi over 6 is negative root 3 over 3. So we have 4 solutions. X equals pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6. Number 5, cosecant squared of x minus 4 equals 0. Isolate the trig function by adding 4 to both sides. Cosecant squared of x is equal to 4. Now, square root both sides. We'll get cosecant of x equals plus or minus 2. It's hard to locate cosecant values on your unit circle, so make a change. If the cosecant value is plus or minus 2, that means the sine value is plus or minus 1/2, because sine values and cosecant values are reciprocals. So let's take out our unit circle and find the angles where the sine value is plus or minus 1/2. Those angles are pi over 6, because the sine value is 1/2, 5 pi over 6, sine value is 1/2, 7 pi over 6, sine value is negative 1/2, and 11 pi over 6. The sine value is negative 1/2. There are 4 solutions. X equals pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6. Number 6, 4 sine squared of x minus 3 equals 0. Start isolating your trig function by adding 3 to both sides. Now divide both sides by 4. Then take a square root of both sides. You'll end up getting that the sine of x is equal to plus or minus root 3 divided by root 4. Since root 4 is equal to 2, we have that the sine of x is equal to plus or minus root 3 over 2. So we're going to take our unit circles out and find the angles where the sine value is plus or minus root 3 over 2. Those angles are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. For each of those angles, we see that the sine value is either positive or negative root 3 over 2. So we have 4 solutions. Ding, 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 ding. Part 3. Equations involving inverse trig functions. The directions are to solve for x, where 0 degrees is less than or equal to x, which is less than 360 degrees. For these questions, we'll give our answer to the nearest hundredth. Tips. Earlier in the course, we said this. Given theta between 0 and 360 degrees, in the first quadrant, the reference angle equals theta. In the second quadrant, the reference angle is 180 degrees minus theta. In the third quadrant, the reference angle is theta minus 180 degrees. In the fourth quadrant, the reference angle is 360 degrees minus theta. Today, we are interested in solutions, so we will need the following equations. In the first quadrant, theta equals the reference angle. Solve for theta. In the second quadrant, theta equals 180 degrees minus the reference angle. In the third quadrant, theta equals 180 degrees plus the reference angle. In the fourth quadrant, theta equals 360 degrees minus the reference angle. In Chapter 4, we learned that an inverse trig function of a positive number will give us a reference angle. For example, the inverse sine of 1/2 will get you an angle in quadrant 1, an acute angle, a reference angle. And once we have that acute angle or that reference angle, we'll be able to find all of our solutions. The other thing we will need is all students take calculus. Number 7, find all the angles x where 3 times the cosine of x is equal to 2. We'll start off like we did for all the other ones. We need to isolate the trig function, so divide both sides by 3. We get cosine of x is equal to 2/3. We need to find all the angles where the cosine value is 2/3. The unit circle will not help us here because 2/3 is not a special number on our unit circle. We have to use our calculators to find our answer. So, how do we do that? We're going to take the inverse cosine of both sides. The inverse cosine of x is equal to the inverse cosine of 2/3. The reason why we're doing this is because inverse functions cancel. So we have x is the inverse cosine of 2/3. Now, go over here and go like this. All students take calculus. Since our cosine value is positive, our solutions are going to be in the first or fourth quadrant. In order to find our solutions, we need our acute reference angle. So now, go over here and let's find the reference angle. Plug in the inverse cosine of the positive 2/3. Make sure your calculator is in degree mode. Our calculator is giving us that the reference angle is 48.1896 degrees. Since our final answer is going to be rounded to the nearest hundredth, 4 spots should be good. Notice also that this inverse cosine function of this positive number gave us our reference angle, the acute angle, in the first quadrant. That's exactly what we need to find our solutions. Now we can use our formulas. Remember, in the first quadrant the solution is equal to the reference angle. In the fourth quadrant the solution is 360 degrees minus the reference angle. So to the nearest 100th our solution is equal to the reference angle, or 360 degrees minus our reference angle. Number 8, 4 sine of x plus 5 equals 2. Isolate by subtracting both sides by 5. We get 4 sine x equals -3. Now divide both sides by 4. Sine of x is equal to -3/4. We need to find all the angles where the sine value is -3/4. The unit circle is not helpful here, so we need to take the inverse sine of both sides. We get inverse sine of the sine of x is equal to the inverse sine of -3/4. Inverse sine and sine cancel, so x is the inverse sine of -3/4. If we directly plug this into our calculator, we are going to get something that might not be useful for you. That's why we're going like this. All students take calculus. In this problem, the sine value is negative, so that means that we are in the third and fourth quadrants. Our solutions are in the third and fourth quadrants. To find our solutions, we need the acute reference angle. To find the acute reference angle, plug in inverse sine of +3/4 into your calculator. Our acute reference angle is 48.5903 degrees. We can use this reference angle to get our two solutions. In the third quadrant, our solution is 180 degrees plus the reference angle. In the fourth quadrant, the solution is 360 degrees minus the reference angle. So, one of our solutions is 180 degrees plus the reference angle, which gives us 228.59 degrees to the nearest hundredth. The other solution is 360 degrees minus the reference angle, which gives us 311.41 degrees to the nearest hundredth. Number 9, 3 times the tangent of x plus 7 is equal to negative 10. Step 1, subtract 7 from both sides. 3 tangent of x is equal to negative 17. Next, divide both sides by 3. The tangent of x is equal to negative 17 thirds. We need to find all the angles where the tangent value is negative 17 thirds. The unit circle is not helpful here, so we have to take the inverse tangent of both sides. We'll get the inverse tangent of the tangent of x is equal to the inverse tangent of negative 17 thirds. Inverse tangent and tangent cancel. X is equal to the inverse tangent of negative 17 thirds. Now if you plug this into your calculator directly like this, you might get something that you don't know how to work with. So that's why we're going all students take calculus. The tangent value is negative. Therefore, our solutions are in quadrant 2 and quadrant 4, because that's where the tangent values are negative. To find these solutions, we need the acute reference angle. To find the acute reference angle, you need to plug the inverse tangent of positive 17 thirds into your calculator. Okay, so plug that in right now. You'll get that the reference angle is 79.9920 degrees. Now we will use this acute reference angle to find both of our solutions. In the second quadrant, our solution is 180 degrees minus the reference angle. In the fourth quadrant, our solution is 360 degrees minus the reference angle. 180 degrees minus our reference angle is 100.01 degrees to the nearest hundredth. Our next solution, 360 degrees minus the reference angle, is 280.01 degrees to the nearest hundredth. Number 10, 4 sine of x plus 7 equals 12. Step 1, subtract 7 from both sides. Now divide both sides by 4. We get that the sine of x is 5/4, or the sine of x is equal to 1.2. We're trying to find all the angles where the sine value is 1.2. For this equation, there's no solution because there are no angles that will give you a sine value of 1.2. Remember that sine values for all of our angles are in between -1 and 1 inclusive. So 1.2 is not a possibility. The same is true for cosine values. All cosine values are between -1 and 1 inclusive. Such a situation will not happen for tangent values. The range of a tangent function is all real numbers. This means that a tangent function can take on any value. Part 4, factoring. Solve for x. Use 0 is less than or equal to x, and x is less than 2 pi, unless stated otherwise. When you're using factoring to solve a trig equation, make sure that you set your equation so that you have all of your trig stuff on one side and 0 on the other side. Number 11, 2 sine squared of x minus sine of x minus 1 is equal to 0. This reminds me of a trinomial, so we're going to do regular trinomial style factoring. There's only one way we're going to get 2 sine squared of x. That would be 2 sine of x times sine of x. The only factors of 1 are 1 times 1. Now we have to fix the sign so that when we FOIL, it adds up to negative sine of x. Here is 1 sine of x, and here is 2 sine of x. If we have plus sine minus 2 sine of x, then that'll add up to negative sine of x. So the signs go plus, minus. Tea time! Set your factors equal to 0, and now we can solve for x on both sides. Over here, subtract 1 and divide by 2 to get sine of x is equal to negative 1/2. Now we're looking for the angles where the sine value is negative 1/2. Those angles are 7 pi over 6 and 11 pi over 6. On the other side, add 1 to both sides. We're trying to find the angles where the sine value is 1. Actually, there is only one angle right here. When x is pi over 2, the sine value is 1. So here are our solutions between 0 and 2 pi. If you're having trouble factoring because of the trig expressions, then just let sine of x equal a. If that's the case, you have 2a squared minus a minus 1 equals 0. And then you can factor this trinomial like you would factor any other trinomial. You would get 2a plus 1 times a minus 1. And then after that, just substitute back in. Remember, a is the sine of x, so that leads to 2 sine of x plus 1 times sine of x minus 1. And then you can go from there. Number 12, 4 cosine squared of x minus 1 equals 0. This is a difference of perfect squares. So we're going to factor it accordingly. We would have 2 cosine of x plus 1 times 2 cosine of x minus 1. Tea time! Set your factors equal to 0. And now isolate your trig functions. We'll get cosine of x equals negative 1/2. So we should take out our unit circle and find the angles where the cosine value is negative 1/2. X equals 2 pi over 3 or x equals 4 pi over 3. On the other side, we'll get cosine of x equals positive 1/2. That happens when x equals pi over 3 or when x equals 5 pi over 3. So we have 4 solutions. This particular problem could have also been solved by using the square root method. We would have gotten cosine squared of x is equal to 1/4. And by taking a square root of both sides, we would have got cosine of x is equal to plus or minus 1/2. That would have led to the same solutions. Number 13, cotangent of x times cosine squared of x is equal to 2 cotangent of x. Remember, before we use our factoring techniques, we have to get trig stuff on one side and 0 on the other side. So step 1, subtract 2 cotangent of x from both sides. We get cotangent of x times cosine squared of x minus 2 cotangent of x equals 0. Right now we have GCF factoring. We can take out a cotangent of x from both groups. If we do that, we're left with cosine squared of x minus 2. Tea time! Over here we'll get cotangent of x equals 0. There are many ways we can handle this side. Way 1. If the cotangent of x is 0, then the tangent of x is undefined. So now we can look for the angles where the tangent is undefined. That would be pi over 2 and 3 pi over 2. Way 2. Cotangent of x equals 0 is the same thing as cosine of x over sine of x equals 0. Cross multiply to get cosine of x equals 0. The angles where the cosine value is 0 are, again, pi over 2 and 3 pi over 2. On the other side, set your factor equal to 0, and we'll have to use the square root method here. cosine squared of x equals 2. Square root both sides. Cosine of x equals plus or minus root 2. That means cosine of x equals plus or minus 1.4-ish. That's impossible. There are no angles where the cosine value is 1.4. So over here, we can reject this side. Remember that cosine values are in between -1 and 1, so 1.4 is out of bounds. The common mistake on this problem is to divide both sides by the cotangent of x. So we'll write this in red. This is not what you do. If you divide both sides by the cotangent of x, you'll end up getting cosine squared of x is equal to 2, which leads to no solution. So by dividing by cotangent of x, you're making the equation smaller. You're denying yourself of that other opportunity that we just saw. That's why I'm saying before we use our factoring technique, make sure we have trig expression on one side, 0 on the other side. Number 14, 3 cosine squared of x minus 5 cosine of x minus 2 equals 0. This reminds me of a trinomial, so we're going to use our regular trinomial style factoring. The only way we're going to get 3 cosine squared of x is 3 cosine of x times cosine of x. Now we got to figure out where to put the factors of 2 so that when we FOIL, it'll add up to -5 cosine of x. After a little experimentation, we'll put the 1 first, we'll put the 2 second. If we do that, we get 1 cosine of x and 6 cosine of x. So if we have +1 and -6, that'll add up to -5 cosine of x. The positive goes with the 1, the negative goes with the 2. Tea time! If you set your factors equal to 0, you will get cosine of x equals -1/3 and cosine of x equals 2. We know that there are no angles where the cosine value is 2, so we're going to reject that side. There's no solution on this side. On the other side, we can't use our unit circle to find angles where the cosine is -1/3, so we have to use inverse trig. We're going to take the inverse cosine of both sides. So we'll get inverse cosine of cosine of x is equal to the inverse cosine of -1/3. We are doing this because inverse cosine and cosine cancel. X equals the inverse cosine of -1/3. Plugging this in your calculator will get you something that will be hard to deal with. So let's use the tips from before. All students take calculus. Our cosine value is negative, so that means that our solutions are in quadrant 2 and in quadrant 3. To find these solutions, we need the reference angle. And to find the reference angle, we're going to plug inverse cosine of +1/3 into our calculators. Our calculators are giving us a nice acute angle, 70.5287. 4 decimal places will be good enough. We'll give our answer to the nearest hundredth. In the second quadrant, our solution is 180 degrees minus the reference angle. In the third quadrant, the solution is 180 degrees plus the reference angle. Our first solution is 180 minus our reference angle, which is 109.47 degrees to the nearest hundredth. Our second solution is 180 degrees plus our reference angle, which is 250.53 degrees to the nearest hundredth. Part 5, using identities. Solve for x. Use 0 is less than or equal to x and x is less than 2 pi. In this part, we will make extensive use of our Pythagorean identities, in particular, the Valentine's Day card. Number 15, 2 sine squared of x plus 3 cosine of x minus 3 equals 0. This looks like a trinomial to me. I want to do trinomial style factoring, but I can't yet. That's because we have a sine squared term and a cosine term in the same equation. Buh! We need to make a change right now so that we have either all sine terms or all cosine terms. Since sine is being squared, we're going to use this identity to make a change. Sine squared is 1 minus cosine squared of x. Make sure we put that in parentheses and then write all the other stuff. Look at what we have. Now we have all cosine terms. So distribute the two. Now combine the like terms. 2 minus 3 is negative 1. We typically do not like to factor when there's a negative leading coefficient. So move all of this stuff right here to the other side of the equation. Basically, we're just going to change all the signs right now. Now we have something that's factorable. It's a trinomial. We're using trinomial style factoring. 2 cosine of x times cosine of x is 2 cosine squared of x. 1 times 1 is 1. The signs both have to be negative. Tea time! We'll end up getting cosine of x equals 1/2 and cosine of x equals 1. So look at your unit circle to find the angles. The angles where cosine is 1/2 are pi over 3 or 5 pi over 3. The angle where the cosine value of 1 is x equals 0. People might also be tempted to include x equals 2 pi as a solution. However, it says in the directions to not include 2 pi, so don't include that one. Number 16. Sine squared of x plus 2 sine of x plus 1 equals cosine squared of x. We can already recognize that we're going to need to factor eventually. We can also recognize right now that there's a problem because we have sine terms and cosine terms in the same equation. If we change cosine squared of x into 1 minus sine squared of x, then all of our terms will be in sine. So that's the change we want to make. Change cosine squared of x to 1 minus sine squared of x. Now subtract 1 from both sides and add sine squared of x to both sides. We'll get 2 sine squared of x plus 2 sine of x equals 0. We have trig expression equals 0. This is a GCF problem. We can factor out 2 sine of x from both parts. If we factor out a 2 sine of x, we're left with sine of x plus 1. Tea time! Set the factors equal to 0. Over on this side, divide both sides by 2. The angles where the sine value is 0 are 0 or pi. On the other side, sine of x equals negative 1. The angle where the sine is negative 1 is 3 pi over 2. Number 17, cosine of x minus cosine squared of x plus sine squared of x equals 0. We want to be able to factor, but we have cosine terms and sine terms in the same equation. We have to be able to recognize to change sine squared. If we change sine squared to 1 minus cosine squared of x, then all of our terms will be in cosine and we'll be able to factor. So let's make that substitution right now. Sine squared is 1 minus cosine squared of x. Now combine the like terms. You'll get negative 2 cosine squared of x plus cosine of x plus 1 equals 0. We don't like factoring with that negative coefficient, so let's move everything over to the other side of the equation. Basically, that means we're going to change all the signs. And then we should be able to factor this using regular trinomial style factoring. 2 cosine of x times cosine of x is 2 cosine squared of x. 1 times 1 is 1. The signs need to go plus, minus. We can do our t time and then use our unit circles to find our 3 solutions. Number 18, secant squared of x plus 2 secant x times tangent of x plus tangent squared of x equals 1. For this problem, we're going to have to use these Pythagorean identities. You might have to experiment for a little while for something like this. In number 18, I'm going to try and change secant squared of x to tangent squared of x plus 1. And then we're just going to see what happens. So secant squared of x is equal to tangent squared of x plus 1. Now we can combine the like terms. First of all, if we subtract 1 from both sides, these 1's are going to cancel. Next, tangent squared of plus tangent squared is 2 tangent squared of x. We have trig expression on one side and 0 on the other side. This is a GCF factoring problem. We can factor out 2 tangent of x from both parts. If we do that, we're left with tangent of x plus secant of x. T time. 2 tangent of x equals 0. Divide by 2. Tangent of x equals 0. Use your unit circle. The angles are 0 and pi. On the other side, tangent of x plus secant of x equals 0. Something like this is going to require some experimentation from you guys. Tangent is sine over cosine. Secant is 1 over cosine. The common denominator is cosine, so bring those two fractions together and cross multiply. Sine of x plus 1 equals 0. Sine of x equals negative 1. Therefore, our angle is 3 pi over 2. Part 6, multiple angles. Solve for x. 0 is less than or equal to x. X is less than or equal to 2 pi. Looks like 2 pi is included in these directions. Number 19, 2 cosine of 2x equals 1. This is called a multiple angle problem because the angle is now represented by a 2x. It's a double angle. First, go over here and note that x has to be between 0 and 2 pi. Our solutions have to be between 0 and 2 pi. In this problem, we're talking about 2 x's, so multiply everything over here by 2. Now we see that 2x is between 0 and 4 pi. From 0 to 4 pi is twice around your unit circle. So this is telling us, this right here is telling us that when we list our angles, we have to go around our unit circle twice. Okay, so now divide both sides by 2. These 2's cancel. You get cosine of 2x is equal to 1/2. We have to list all of the angles where the cosine value is 1/2. In other words, we're listing all of the 2x's where cosine is 1/2. So now we have to start listing our angles, and since 2x is between 0 and 4 pi, we have to go around our unit circle twice. Okay, so start going around, boom, pi over 3. Continue going around, boom, 5 pi over 3. Remember, we have to go around twice, so go around, and boom, we found another one. 7 pi over 3. Keep on going, keep on going, keep on going. Boom, 11 pi over 3. Those are all the angles between 0 and 4 pi. So let's summarize. When it comes to listing the angles, we need the angles where cosine is 1/2. We got pi over 3. 5 pi over 3. That was going around the unit circle once. Now we have to go around again. Every time we go around the circle, just add 2 pi. In other words, just find coterminal angles for these guys right here. Pi over 3 plus 6 pi over 3 is 7 pi over 3. And then 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. So that's our other angle, 11 pi over 3. Now remember, we're trying to solve for x, so in the end, divide all the angles by 2. That's the same thing as multiplying all the angles by 1/2. So our solution is x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Notice that all of our solutions are indeed between 0 and 2 pi. Number 20, 2 times the sine of 3x plus root 3 equals 0. First, go over here. Our solutions have to be between 0 and 2 pi inclusive. The angle is represented by a 3x this time, so multiply all this by 3. We see that 3x is between 0 and 6 pi inclusive. 0 to 6 pi is 3 times around the unit circle. So when it comes time to list our angles, we have to go around that unit circle 3 times. Okay, time to isolate our trig function. First, subtract root 3 from both sides. Next, divide both sides of the equation by 2. These 2's cancel. Sine of 3x equals negative root 3 over 2. So now we have to list all the angles, that is, list all the 3x's where the sine value is negative root 3 over 2. We have to go around the unit circle 3 times. Okay, we're starting to list angles, so follow along with the unit circle. Bam, 4 pi over 3. Keep on going around. Boom, 5 pi over 3. Okay, take a look at the green wall. That's 1 time around the unit circle. We have to keep on going around. We're going around, we're going around, we're going around. Boom! Every time we go around the unit circle, we must add 2 pi. That's the same thing as finding a coterminal angle for 4 pi over 3. So, 4 pi over 3 plus 6 pi over 3 is 10 pi over 3. Continue going around. Boom! So find an angle coterminal with 5 pi over 3. 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. Okay, green wall, that's twice around, but now we have to go around the unit circle a 3rd time. Going around, going around, going around, boom! We got to find an angle coterminal with 10 pi over 3. 10 pi over 3 plus 6 pi over 3 is 16 pi over 3. Continue going around the unit circle until, boom! We got to find an angle coterminal with 11 pi over 3. 11 pi over 3 plus 6 pi over 3 is 17 pi over 3. In the end, remember you need to solve for x, so divide everything by 3. All these angles divide by 3. That's the same thing as multiplying by 1/3. This will make it so that the angles are back in between 0 and 2 pi. Okay, so here are our solutions, and notice that they are between 0 and 2 pi. Number 21, 4 times the tangent of x over 2 minus 4 equals 0. Solutions have to be between 0 and 2 pi inclusive. The angle in this problem is represented by x divided by 2. It's a half angle. So, multiply everything by 1/2. We see that x over 2 is between 0 and pi inclusive. This means when it comes time to list our angles, we only have to go halfway around the unit circle. Okay, go over here and start isolating the trig function. Add 4 to both sides. Now divide both sides of the equation by 4. These 4's cancel. Tangent of x over 2 equals 1. List all of the angles where the tangent value is 1. In this problem, the angles are x over 2. Take out your unit circle and find all of the angles where the tangent value is 1. Ding, 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 ding. And we only have to go around the unit circle halfway. Pi over 4 is the only angle between 0 and pi where the tangent value is 1. So x over 2 is equal to pi over 4. So make sure you're seeing that there are no other angles where the tangent value is 1 going halfway around the unit circle. To solve for x, multiply both sides of this equation by 2 and we'll get x equals pi over 2. 22. 4. Secant squared of x over 2 equals 8. Solutions are between 0 and 2 pi inclusive. Our angle is represented by x over 2. Multiply all of this by 1/2. X over 2 is between 0 and pi inclusive. When it's time to list angles, go halfway around the unit circle. Time to isolate the trig function by dividing both sides of the equation by 4. We see that the 4's cancel. Secant squared of x over 2 equals 2. Square root both sides. The square and the square root cancel. Secant of x divided by 2 is equal to plus or minus root 2. If secant values are plus or minus root 2, then the cosine values are plus or minus 1 over root 2. Rationalize, and we see that the cosine of x divided by 2 equals plus or minus root 2 over 2. So list all of the angles where the cosine value is plus or minus root 2 over 2. Angles in this problem right now are x over 2. Remember, we only need to go halfway around. Boom, pi over 4. Keep on working your way around the unit circle until, boom, 3 pi over 4. X over 2 equals pi over 4, or 3 pi over 4. That's halfway around the unit circle. To solve for x, multiply those angles by 2, multiply both sides of the equation by 2, and we'll get our solutions. X equals pi over 2, or x equals 3 pi over 2. Notice that our solutions are in between 0 and 2 pi. Okay, before you do your homework assignment, I recommend that you do part 7. There are 10 good problems in this section that will allow us to practice the material that we just learned. When you get done with part 7, check your solutions. They're posted on the website. The homework for this lesson is on page 394 of your book. It is 11 to 43 odd. For these problems, I want you to solve for x, and I want you to put solutions between 0 and 2 pi. 0 included, 2 pi not included. Make sure you're checking all of your answers on CalcChat. This is section 5.3 in our book. Chapter 5, section 3. Also remember that your independent study packet is due, so make sure we're finishing that as well. Good luck, and we'll have time in our next class to go over any questions, comments, or concerns that you have about this material.